Hello, welcome to Reaction Norm. My name is Michael McConkey, and this is the world's leading podcast on biology in culture and politics. And I'm joined today by my esteemed colleagues, Patricia. Patricia, how you doing?
I'm good, Michael. It's a beautiful day in the neighborhood.
It looks lovely behind you there. Looks like a very nice day in the neighborhood. Mm-hmm. And Charles is here too. How you doing, Charles?
I'm doing well. Like Trish said, it's a gorgeous day outside. It's sunny. I think it's like 14, 15 degrees outside, which is fantastic. And so you might have noticed that the background's different where I am.
Where'd the bricks go?
Yeah. So we moved to a larger office. And last time I got the bricks behind me, and to be fair, this time one of the other people in the office got the bricks behind her. So that's fair. It's just my background doesn't look as nice now. I am thinking about setting something up. Like I have these bars where I can put a backdrop, so maybe I'll do that at some point. But we'll see. And
along those lines, we should mention that we came very close to recording this episode at the new Reaction Norm studio in an undisclosed location in Vancouver, but it didn't quite work out. But we will in the future do a episode from the secret Reaction Norm studio and see how that works. Maybe that might be a better system. So we'll give that a try. But for now, we're still here on Zoom with our tiles, or our three birds. But I do kind of like to. All righty, so okay, a bit of housekeeping stuff. As we move towards summer, as we record this, it's early May, and we're going to have a couple more episodes that we're going to be able to do. But people are going to start becoming scarce. Patricia's going to be away in June, and I know Charles has various trips planned. These two both have significant others. I do not. So for anybody watching, like if you're looking for like an attractive, charming date to talk about evolutionary biology with, right? I'm the only one that's available of this group. Okay, so so these two both have significant others and will be away at the other times doing things. So probably over the course of the summer, we're probably going to slow down to maybe every 2 weeks or something once we get into June. But in September, hopefully we'll be able to pick right back up with our weekly episodes. But just a warning for those who watch regularly, and I know there are some who do watch regularly, that we will be going probably to every 2 weeks once we get into the nicer weather. Alrighty, so today's provocative title of our program is going to be something along the lines of everything is genetic, according to Michael. So I'm going to try to persuade Patricia and Charles that everything is genetic. Now, there are a couple of qualifications before we start. Okay, the first qualification is that I'm only making this claim in relationship to that which is produced by evolutionary processes, right? I'm not saying evolutionary processes themselves are only genetic, obviously. You got to need, various physical forces acting upon genes to cause evolution to take place, but the production of that, the behavior, the cognition, the perception of us as humans, and I would say of all animals, is all about genetics. And this, of course, goes directly to the classic debate around nature and nurture. So I'm arguing 100%, 100% on the nature side. Though, of course, naturally, there's an interesting way in which I get there. So, and I have another qualification, but before I get to that qualification, maybe, I thought that maybe we should pass the torch here, because I know, Patricia, you said that you were going to for those who we don't want to be overly corrupted by my point of view, we want to give them the actual official scientific point of view. So you were going to actually put together a few remarks to let people know what the sort of standard consensus position is on this before I give my radical outside the box position.
Yeah. So I can talk a little bit. This is just going to be like the Wikipedia entry version of this. So anybody, you're free to jump in if there's something you want to add. But I thought it would just be, we'd sort of, I was going to frame it by just a very brief history of the argument. So the phrase nature versus nurture, we got this from Francis Galton, who was a scientist and a number of other things in the 19th century, and sort of came out when they were studying, when people were starting to learn about evolution and heredity. And now we kind of use it more specifically to talk about is something sort of your genes, or is it the environment? And so if you've got sort of the nature side, which would be your genes, it's like pretty self-explanatory. You get 23 sets of chromosomes, and those kind of determine who you are, right? You've got your eye color, and you get genes to determine how tall you might be. And so it's like this idea that you as a person come with a lot of stuff hardwired into you that you can't change. And so if you go full nature, which I know Michael's going to get into it, but like sort of, let's talk about the argument that people talk about what they don't like about sort of going full nature is this idea of genetic determinism, right? It's that it can kind of get warped into some not very nice ideas about eugenics and discrimination. And so there's a lot of worry that we're going to end up in this sort of like Gattaca world where people don't even have like an opportunity to, freely pursue what they want because there'll be so much discrimination. And also it sort of feels bad on an emotional level, genetic determinism, that you don't feel like you're, like the captain of your own ship. So people kind of don't like that idea of genetic determinism because you would try and like, it often gets sort of warped to people to try and discriminate against other groups, such on. Anyway, so then you've got the flip side, right? So you've got nurture. And so this sort of came around in the early 20th century with the idea of behavioralism. And sorry, I had my wrong note out. And so this is the idea is that your genes don't matter at all. We're all born sort of nice little blank slates with your like blank hard drive that society and culture and people sort of download all their garbage onto. And so this traces back to, the Lockean tabula rasa. And this was it was almost more of an ideology. Like the whole problem with this side of that everything is the environment and nurture is that there was never really any good science for it. And it just seemed to be more of a political ideology that, science was something that was being used to repress people. I actually have a good quote. Let me pull up the quote that I wanted to read. Which was, so this is like classic behavioralism, John Watson, give me a dozen healthy infants, well-formed, and my own specified world to bring them up in, and I'll guarantee to take anyone at random and train him to become any type of specialist I might select. Doctor, lawyer, artist, merchant, chief, and yes, even beggar man and thief, regardless of his talents, penchants, tendencies, abilities, vocations, and race of his ancestors. I am going beyond my facts, and I admit it, but so have the advocates of the contrary, and they have been doing so for many thousands of years. So that's like behavioralism in a nutshell. We have since sort of dismissed that idea, and it's become a much more sort of nuanced mix. So in the second half of the 20th century, they started doing a lot of twin studies. And so this would be with genetic and fraternal twins that were raised together or separately, and realized that, it's probably a mix. So for a while, the prevailing wisdom was that it was sort of 50-50, right? Like 50% nature, 50% nurture. And in that, I don't really have a lot else to say. Yeah, the 50-50 mix. And since then, I would say that we've even tried to get rid of this idea that it has to be one or the other. It's sort of become more of a narrative of nature and nurture, that you have genes and they interact with the environment, and your genes shape the environment, and your environment is shaped by your genes shape your environment, but obviously your environment can also affect your genes, and you get into stuff like epigenetics and gene expression. So that's sort of where we are now. We're depending on the trait on a population level. Some things are much more sort of environmental, and some things like eye color and, some like diseases like Huntington's or whatever are going to be completely genetic, but we're sort of dealing with it on a more trait by trait basis and trying to inject more nuance into it.
That was a great introduction. You actually convinced me. I actually surrendered my position. I was wrong. So Charles, is there anything you want to amplify or add to that?
Yeah, I would say that I think a lot of people, when you say the word genetic, what they have in their mind is a kind of destiny, but it's that there's a single destiny, right? That you have these genetics, this will be the result of your life no matter what. And that doesn't seem to be, I think, an understanding that's accurate. Like you have genes, and they affect how you react, but there's a range of the ways your genes can cause you to react, right? I think if you're in the warm weather, okay, you'll have a certain reaction. If you're in the cold, you might start shivering, right? And your genes control that, but there's a range of the reactions you have. Now, one individual, the genes can give them a certain kind of rage and make it so they're more likely in certain parts of that range than not. Like maybe one person shivers at a lower temperature than another, right? And another person, like, they shiver at a higher temperature than the other, right? So there's an effect by the genes, but it doesn't mean there's like one single destiny.
Yeah, that's right. And I don't think that's a good qualification, because I don't think the argument that I'm going to make that everything's genetic leads to the assumption of some kind of crude monolithic outcome from your genes. I think you have to keep in account that there's a reaction norm to the phenotypes that result from any particular genetic outcome. All right then, so with the truth, with reality laid out clearly by Patricia and Charles.
I don't know if that was the reality, but
But I'm going to try and change reality now. Here we go. I'm going to try and change reality. So I said there were two qualifications. One's I'm only talking about the nature nurture thing. The other qualification here is that I'm not claiming anything new in terms of the science. What I'm claiming is that I want people to shift the way that they look at the problem. And this can actually have huge impacts, right? I mean, this is effectively what Copernicus did, right? I mean, like prior to Copernicus, all the astronomers knew what the heavenly bodies did, but because they were fixated on the idea that the Earth had to be at the center, they came up with these very bizarre looking, like if you look at maps or descriptions of the mechanics of the solar system prior to Copernicus, you get these weird sort of orbits upon orbits sort of thing and all these sort of weird mechanics, because they had to somehow try and make the things that they observed, including the apparently retrograde motion of the planets, they had to make it look like it would work on this. They have these crazy systems, and all Copernicus did was that, well, if you just put the sun in the middle, then everything's very simple. It's just everything goes around it, right? So that's all I'm suggesting here, right? Let's just shift the way we look at it, and maybe we can gain some kind of better insight, or more better. I'll say with better. All right. So I have a question for you guys to start. You probably never heard this question before, but I'm going to ask you this question because it's important. All right. So if a tree falls in the forest and nobody's there to hear it, does it make a sound?
Yes.
Patricia?
Is this a trick question?
It is a trick question. Of course it's a trick question. So this of course is an old question everyone knows. And from my point of view, the answer that you give isn't important. What's important is the question itself. The question apparently goes back to George Berkeley, Bishop Berkeley, philosopher who put it forward in a book in the very, very early 18th century. And so this question's been around for like 300 years. And I think why no one can ever give a satisfactory answer to this question, because it captures a certain problem. And this problem is that we acknowledge that there is an objective material world, but we also understand that we don't necessarily interact with that objective material world, or to the degree, or our experience of it is not an experience of an objective material world. And this, I think, is the key point that I want to emphasize here. So when we talk about genes and environment, let's be clear what the word environment means, because people use the word environment in a lot of different ways. So etymologically, what the word environment means is right? It means to surround something. So an environment only exists to the degree that it exists for something that is surrounded or enveloped by the environment. The environment is subjective to the thing that is experiencing or for whom the environment is a relevant factor, right? So the environment is not the objective material world. The environment is some aspects of the objective material world that some other entity is creating or experiencing. So my claim here is that all environments only exist for genes. Some cluster of genes is always at the center of some environment. And more than that, I'd say those genes actually create that environment. Like, it's imagine the natural objective world was just sort of a lump of clay, and some group of genes come along and take some parts of that. They don't take the whole clump of clay, they take some parts of it and they mold it into something that's relevant to them. And so, for instance, so I can give you some examples of the kind of thing I'm talking about. So think of vision. So most of us walk around thinking that, we see the world, right? We can see the world as it is. But of course, lots of different kinds of species, and therefore different combinations of genes, because we're talking about, right? We're talking about different individuals, see the world quite differently than us, right? I mean, so we have like 3 sets of these photoreceptors, right, that allow us to sort of see the 3 kinds of colors and different combinations for that. There's other animals, clusters of genes that can only see 2 photoreceptors. There's others that, like birds, have like 7. Some birds have 7 photoreceptors, so they see way more color than we can. There's something called a mantis shrimp that I think has 12 photoreceptors. They actually see 12 different places, parts of the color spectrum, right? Plus, there's things things like ultraviolet light and infrared light that also we can't see that others can see. Snakes can see infrared. Some birds can see ultraviolet. There's things like bees can see polarized light that we can't see. So there's all these different things. Now, these all exist because of historical evolutionary pressures that have borne down upon these sets of genes, so that there's particular combination of genes, a particular structure of organism and behavior of organism that they create benefits from seeing those particular colors, or that particular visual part of the world. But my point is that actually is the environment of those species. So in a sense, what they do, they create their environment. The genes are creating their environment by creating a visual system that can take from the material world the visual elements that are relevant to that particular cluster of genes and the particular organism that it creates. I have other examples, but that's sort of like a first pass at the situation.
Can I ask questions?
Yeah, absolutely. I was just going to say, floor is now open for comments and questions before I go on.
So would you say that you have to be able to interact with something for it to be in your environment?
That's okay. So I'm going to actually have my next example is going to touch upon this.
Okay.
So I would say that the things can affect you that are not part of your environment, right? So if every that's why evolution takes place, right? If a particular cluster of genes and the organism they create, had sort of the perfect symmetry, a perfect relationship with their environment, and everything that was their environment was their only experience of the natural world, they would never evolve anymore, right? But it's because things come from outside that are unexpected that therefore they, some of them die off, and you get the possibility for mutational selection and stuff that causes it to change and become something else. So I'm not saying the objective world doesn't exist outside of the environment, but I'm saying the environment is created by the genes, but something can come from off stage. It's like an actor, right? You create your nice little story, and you're on stage, you're doing a play, everything's sort of fun, everyone's doing their lines, and some idiot runs up from the audience and starts screaming, right? That's not supposed to be on the stage, but it's there and you got to deal with it, right?
Right.
So that's sort of the way I see the relationship between the material world and the environment.
So a comment I have is that what you laid out, I think, is very much in line with the definition of environments that's typically used from an evolutionary adaptation point of view. And this is the contrast with when the word environments is used in the behavioral genetic sense. Those two things, which is the result of an equation, or actually a number of equations, but those two things mean something very different, even though people use the same word environment for both. I think it also leads to a lot of confusion. I've seen people discuss evolutionary adaptation and talk about the environment, and then someone in the comment section will mention something about behavioral genetics, and it's like, it's not even the same like word really. I mean, it's the same word, it's just they don't mean the same things. It's not
Sorry,
relevant.
can I just have you like circle back to what the behavioral genetics like term environment would mean, just so like we're very clear on what the two definitions are and which one we're.
So Michael's talking about, and I think he did a good job of going over it, the evolutionary adaptation sense of the environment. So it's basically, you have an organism. If you want to think it, for people who have a background in, say, computers, if you think about programming, you have a procedure, right? Or a function, or what do you want to call it? It has inputs, it does something about that, right? From an evolutionary adaptation point of view, environment is like the inputs of that function or procedure. It's what kind of like can like affect its output potentially. A behavioral genetic sense, they have a different sense of environment. So they do certain experiments where they try to say, okay, this is a hereditary component, and the rest, what's left over, gets thrown into environment. And they have different kinds of environment, like they have the shared environment, non-shared environments. But it's like the remainder of like what they don't consider hereditary. And hereditary it suggests biological. So that's a leap they make. Biological suggests genetic, but it's not always the case, right? Like you can compute the heredity of like someone speaking the English language, right? Now we know that's not genetic, right? Even though it can be quite heritable, right? But it's basically an interpretation of the data. Like the behavioral geneticists are trying to figure out, what are the genes affecting and what's the the environment in a sense, like although they're kind of loose about it, at least when you start to construct this, right? What's the environment? It's like basically what's nature versus nurture, right? And they have a way of going about that. There's criticisms about it. Lately, they've been trying to incorporate molecular genetics. I think it needs a lot of work, but
would it be fair to say that there would be like a significant amount of overlap in these two definitions?
I wouldn't. I think they're actually quite different. I think a large area of confusion are when people mix up environment in the evolutionary adaptation sense with environments in the behavioral genetic sense. I think they're like way different. I don't even think you should use the same word. I think it's harshly confusing to a lot of people.
So in the behavioral genetic sense, environment is just sort of what's left over after you talk about heredity.
Yeah.
And okay.
So and that's so thanks, Charles. And I did start off by defining environment because precisely for that reason there are and there's even more definitions of environment than that, right? But that's the one that will often be confused, right? People who mix these disciplines together or dip into both these disciplines will see these terms used in different ways, and if they're not clear about the difference, then it can lead to confusion. So absolutely, I'm not using it so much in the behavioral genetic sense, even though what I'm saying I think bears upon the behavioral genetic domain. I'm not using it so much in the way that they do, which is more probably could be more thought of as being part of the objective material world. So okay, go on and give some more examples to sort of try and flesh out my point.
Yeah.
Okay,
please.
So far we've been talking about the way that we create the world visually, as it were, the way genes create the environment for us that we experience. And it's worth noting too, by the way, that probably to see, you probably has to be a limit upon what you see for you to be able to see anything, right? I mean, I don't know this, but I'm guessing that if you took a bunch of paint, right? Say you had a piece of paper and you had a little square and you just kept painting colors over. So you painted yellow, then you painted green, then you painted blue, and you kept going, you just end up with black, right? You wouldn't actually have any colors anymore, right?
Well, I maybe can help you with that a bit. There is some evidence that suggests that to be able to really function, right, you need to be able to ignore a lot of stuff. So you need to be able to be selective about what you pay attention to, right?
Yeah, that's right.
That happens at multiple levels. It could be, for example, that think like color vision, right? Like you're ignoring like most the electromagnetic spectrum. Like visual light, what we can see is a small fraction of the electromagnetic spectrum. And there's stuff that's near it, right? Like infrared is like close to what we can see. Ultraviolet is close to what we see, but there's a huge range that we ignore. And you're right, there's all sorts of things that We also don't pick like polarization of light. But by the way, we do have the ability to see like luminance, like, black and white type stuff. So we have a bit more than just the color vision.
Yeah.
But it also happens at the level of, you have eyes and you're looking, right? And there's things that you focus on, right? And there's even some work within the realm of, if you want to call it computer vision or machine learning, artificial intelligence, where they found that being able to be selective about what you focus on makes it so that you're more able to do this in real time, right? Like, theoretically you could pay attention to the whole thing, but in practice, if you need to do this, like as, like with a robot or like a humanoid or something like that, you have to be selective. It seems to be too much to compute. So being able to filter stuff out seems to be important.
Yeah, and I'm guessing, and again, I don't, this is just, I actually don't know what this is based on, to tell you the truth, but it's based on things I've read that I can no longer recall, right? That's that kind of thing, right?
Yeah.
But it's not just that you can't compute it, though I'm sure that's true, but I think it's also probably true that you need to, if you could see everything, you wouldn't see anything, right? You have to see, so things have to be in contrast for something to actually be visible, right?
Yeah.
So if you could see every single, whatever it would mean, every spot on every wave of the, the visual spectrum, you probably wouldn't see anything, right? Because you'd have nothing in contrast, right?
Our vision does like all sorts of things, like so I don't know if you know what an edge detector is. Like if you look at you can, like, it's conceptually flat, but you have like two of them from each eye, right? And then there's edges between like objects. Now those aren't actually there. Like if you ever tried to like, if you have say a software engineering background, if you ever try to write a program for that, it's really, really hard to do, right? Like if you don't think about it in certain ways, right? It's not obvious. Like there's mechanisms that go through and find the edges, right? And it seems like our visual cortex layer 1. So this is, you have light coming to your eyes, it projects to the back of your skull somewhere. And there's this area called of your neocortex called visual cortex layer 1. And part of what this does is it seems to find edges, right? And you seem to, like, at different layers within your brain and your mind, it seems to kind of like paint, I don't know if paint, so it seems to attach this kind of, let's say, metadata, like data, like it basically, you can think of like kind of interpreting it, but like putting layers on top of it. So you get like the raw image, and then you have edges and you have other things. And even like the way we perceive colors is kind of interesting. For example, if you think of the cool colors, right, like green and blue, these tend to be like background elements, right? It's like, it could be like a grass field, the sky, water. If you think of the warm colors, right, they seem to represent like animals or fruits or something like that, like something we might want to pay attention to in a different way. But anyways, there's lots and lots of things about this. I'm just mentioning a couple like layers of information that our brain and mind seems to put over this. There's a lot more, and I'm not going into it right now because this will be too big of a tangent.
Yeah. But I guess so the point that I was making, and I think that we all agree upon this then, is that different species, which I think of as different clusters of genes, produce visual systems that have been molded from the past by evolutionary pressures to create environments that allow this particular cluster of genes / species individual to interact with the objective material world in a way that's fitness enhancing for that cluster of genes, right?
So in the sense of creating the environment, it's like what inputs is it able to detect, right?
Yeah, right.
Like think of like a vulture. Vultures, dead meat, for example, is very interesting, and they seem to have specialties associated with that. Interestingly, like the way animals can perceive stuff seems to even affect their sexuality.
Okay, but don't. Okay, you're beginning to trample upon my examples.
Okay, sorry.
Let me go again, because I have fun examples. I thought of fun examples. Let me give you my fun examples. If we assume that if we agree that that's true, that in visual terms, the environment is created by the genes in the same way, right? So I would say that if you look at other kinds of animal behavior, we find the same kind of thing going on, where things that seem remarkably bizarre to us as the observer seem normal to that species because of the environment that it's created for itself, because of these past evolutionary pressures, right? For whatever it is, and the way in which we can also manipulate that. So there's a couple of I think interesting. What is this? That's weird. A couple of interesting animal examples that I quite like in this sort of context. So one of them is and by the way, I was going to say that. Oh, sorry, Charles, were you going to say something?
What was one of the examples of vulture?
No, it wasn't actually a vulture. I was just afraid you were talking in ways that were getting too close to my to my examples. By the way, so the first, because humans are so visual, the first thought might be here to think of this in visual terms. And of course it has visual dimensions, but think of these examples also, they have other examples, including tactile. I mean, the tactile dimension of this is very interesting, right? But you'll understand more what I mean when I give the example. So 2 examples. So the first example is meerkats. So meerkats are this weird little animal that I think lives in Africa. And one of the things it eats is scorpions. And so it feeds its children. Now, I can't remember the exact ages, but we'll just have categories. The exact ages are important for this point. So let's say children go through an infant, child, and adolescent phase, okay? Well, just whatever the actual ages correspond to that, okay? So what the meerkats do then is that when their children are infants at the youngest age, what they will do is they'll catch the scorpion, they'll kill it, and they'll remove the stinger. And then they feed the dead stingerless scorpion to the infants. Now, when the children grow, when the offspring grow up and become children, the older group, what they'll do is they'll catch the meerkat parents will catch the scorpion, break off the stinger, but give the live scorpion to the children, so they have to kill it and eat it, right? And take care of themselves. And then when the offspring get to be adolescents, then they'll catch the scorpions, and they will neither kill it nor remove the stinger. They give it to the adolescents like that and say, basically, okay, you're old enough, you have to learn how to do this. You're either going to die or you're going to, learn how to eat these things, because, that's what we eat, right? So this is the normal process. But it turns out that if researchers record the voice of infant meerkats, no, excuse me, I got that wrong. If they record the voice of adolescent meerkats, the oldest of the 3 categories, and they play those sounds, the sound of the voices of the adolescent meerkats, when the babies are actually infants, the parents will catch the live scorpion, not kill it, not remove the stinger, and give it to their infants. Now, this, you would get in, like, you would think, they should be able to see that they're little tiny things, right? And they're, they have presumably some kind of tactile interaction with them, right? I mean, surely they should see that, these are too little to be giving live scorpions to with stingers to, but apparently they are only cued by the actual sound of the voice. The sound of the voice is the only thing that they have been sort of evolved to tap into. So their environment, as it were, is this constructed around the sound of the voice. And if you mess up their environment in some way, then they behave in ways that, are counterintuitive and counter fitness, in fact, in terms of preserving their offspring. So second example, which is not the same, but similar in some ways. So the brood parasite birds, right? So birds like cuckoos that lay their nests in the nests of other birds. And I think the example I heard this about particularly was a relationship to cuckoos and finches, but I think this is pretty common among these kinds of arms races, among these kinds of birds. So it turns out that when the cuckoo lays its egg in the nest of let's say the finch, the eggs look a lot like finch eggs. And the reason for this, from an evolutionary perspective, is that the finch mothers are pretty good at distinguishing eggs that don't belong, and they will throw the eggs out. And one of the reasons that this makes sense is because it's early enough in the reproductive season that they can hatch more eggs and start over again if they make a mistake and throw the wrong egg out or something. So the eggs, from evolutionary pressures, it's evolved in such a way that the eggs are very similar, and that's why cuckoos can be successful, because it's hard for finches to distinguish the eggs. However, when the chicks are born, very quickly, the cuckoo chick becomes massively bigger than the finch. I think they can be 4 times the size. You see pictures of this. It's remarkable. They're gigantic. And yet the finch mother who would have thrown the egg out weeks ago if she realized it was a parasite egg, continues to feed the cuckoo chick, despite the fact that to us, it obviously isn't her chick, right? It obviously isn't a finch, right? So in her environment, what's become relevant is the size of the eggs, but the size of the chicks are not. And the thinking here is because it's too late, right? If she were prone to throw her chicks out of or throw chicks out of her nest and kill them, have them die, then she could make a mistake that hurt her fitness. So at that point, it's probably better in evolutionary terms to even feed the ridiculously large, demanding cuckoo chick, because you can't make a mistake at that point because you can't make up for it, right? So these are examples to me in which we have the things that seem bizarre in terms of, from us looking outside of it, like bizarre. Like, how can the meerkat not see that these are little tiny infants that can't handle live scorpions? Or how can the finch not see that, these are giant, giant parasite birds in her nest that she's feeding, rather than her own baby? And so these are ways in which we see in which they've built an environment that takes in some part of the natural objective world, but totally ignores other parts because for whatever evolutionary reasons, it just isn't, it isn't relevant to them anymore. And I would say that probably, this is true of humans. I'd say it's true of humans in two ways.
Yeah.
First of all, humans fall victim to all kinds of patterns of behavior that they don't recognize, right? So for instance, it turns out that, in behavioral genetics and different disciplines, spend a lot of time talking about how irrational we are in how we respond to some of these patterns. But people learn to exploit these patterns too. But it's interesting that for instance, if I ask you for a big favor and you say no, and then I ask you for a small favor, you'll probably say yes. Right? Because you feel kind of bad that you said no to the big favor, but I make a smaller one. Okay, I'll compromise, right? But here's the tricky part. Once I get you to commit to a small favor, it's easier to get you to commit to a big favor, right? So these are the kind of patterns that people don't see, and these go on in our lives all the time. Like I said, behavioral genetics and different disciplines recognize these kind of patterns, and we're kind of blind to them, but they influence us all the time. Their influence our choices. So there's that kind of thing. Plus, there can be stuff like maybe stuff that we can't see. Like we look at the finch and say, how can you not see how big that thing is? That isn't your baby, right? I wonder if there should be some other intelligence, an alien intelligence looking at humans, and there could be something just as obvious that we can't actually see because it's just not part of the environment that we've evolved to create for ourselves, right?
Doesn't the cuckoo push the other chicks out too?
No, apparently not.
Oh,
Apparently
no. Okay.
not. No.
So I've got an example that I think it's like the cuckoo. So I need to work up to it. So the cuckoo is actually something I was thinking of. But let me tell you a bit of a story. And I remember reading this a long time ago. So there's these beetles in Australia. I can't remember what they're called. But what happened is that people would throw away these beer bottles. There were these brown beer bottles, and they had these little dimples on the bottom. And apparently the males of the species of this beetle found it really sexually attractive. So much so they kept on trying to mate, with the bottom of the bottle, and not going after actual females. And some people thought it was a big problem. What happened eventually is that the beer manufacturer changed their bottle, right? And so species saved. So then let's get to humans, right? So humans do have something like this. You might think these beetles are crazy. Why are they trying to mate with that? Porn, right? So you might say, okay, you look at porn, you watch this, you stimulate yourself. That's not a woman. You're not going to result in getting children, right? But yet the stimulation, people still do it, right? And they do it to the point that, they're not pursuing after for example, if males are doing it, they're not going after women. You're not potentially getting them pregnant, whether it's intentional or not, and reproducing, right? Okay, so that's another example. And so this last example, this isn't mine. A friend of mine on Twitter, I don't know if he wants his name said, so I won't say it, but I'll just say it's not my idea. But he said I thought it was quite interesting. He suggested that dogs are like a brood parasite for humans, right? So you have humans who will get pet dogs. They take care of them. They treat them like their children. They raise them, et cetera, et cetera. But, they're not having children of their own, right? So I thought that was actually a quite interesting idea. Now, I'm not saying all dogs in all instances, like there seems to be a kind of like a mutualism going on between humans and dogs in many instances, but at least in the developed world, the way people have pets, right? They almost act like a brood parasite. So,
Yeah, I've heard that argument made for cats. I find it more convincing of cats, actually, because I mean, dogs have a long history of hunting together and that sort of thing, right? Like dogs, I can see historically dogs did a lot for humans. I'm not sure how much cats have ever done for humans.
Are you kidding me? Who do you think keeps all the mice out of your house?
Okay, all right, fair enough. I suppose that's true, yeah. And that's one of the theories, is that's how humans and cats got involved, right? Is that the early cats were when humans started storing grain, and it would attract, mice, and then the cats would come around to hunt the mice and rats, and eventually the humans and cats hit it off or something. That's one of the theories I've heard anyways.
Yeah, it wasn't like intentional domestication. It was sort of like the cats self-domesticated because they would eat the mice, and people were happy about that.
The ones that tended to approach the humans would probably be a little more tame.
That's right, yeah.
And that's, if those ones started breeding among each other, you would get a tame breed eventually.
A bit like your foxes, right?
Yeah.
What episode is that? Episode 10.
So my point here and all this. So by the way, when you were saying that, Charles, I was thinking, imagine this, okay? We can as researchers, we can mess around with the meerkats, right? We can sort of, let's bring in this tape recording and see what happens, and see what they do with the babies and the scorpions. We play this. So imagine some other more intelligent species out there is watching us and saying, what if we introduce pornography? I wonder what will happen. I mean, that would be, I mean, you could think of it that way, right? I mean,
there's even potentially stuff that we can't detect. Like I kind of remember seeing insects like hypnotize other species where they could was it ants? I remember seeing them walking around, like a predator walking around this other species and just picking them off and eating them. And the members of that species just can't detect them for whatever reason.
Right.
And I think I remember an episode of some sci-fi TV show where they were suggesting, for example, they were large, earth creatures that were hypnotizing humans, and that they couldn't detect them, but they were actually predatory and just picking off humans, which I thought was kind of an interesting episode. But it's kind of fun to wonder about that kind of stuff.
Yeah, but that would be, so, and going back to the original point, that would be part of the environment, right? So part of what I'm emphasizing in these examples then are ways in which those who are not part of the other species or the other cluster of a gene's environment can stand from outside and look at it and see things that they can't see. So, for the finch, very much part of its environment is this, being able to distinguish eggs. But because the cost benefits aren't the same later on in the mating season, they don't seem able to distinguish between the full-blown chicks and what seems to us rather obvious. So that's a way in which we get a glimpse into the environment created by the genes of finches. It's created an environment that's relevant to its own fitness, and being able to distinguish the chicks as they get older, especially as the cuckoos become so large, there's just no benefit to being able to distinguish, and therefore the genes have not created whatever receptive systems would be necessary to distinguish the chicks, while it has created the ones necessary to distinguish the eggs.
Well, I think there's kind of two phenomena going on. One of them is kind of a hiding phenomenon, right? You either kind of mask yourself in terms of what it can see, or you kind of you're in a space where it can't detect it. The other thing is they stimulate the other organism in a way that causes them to behave in a certain way. I think with cuckoos, for example, they have under their wings, they have things that kind of look like beaks, and it causes the host parent to not only feed them in their beak, but feed them under their wings, right? So they're stimulating them in certain superlative ways, right? So it's kind of a deception going on, but also using what they detect, their environment, what inputs they're able to detect, stimulating that in a certain way to cause them to behave in a certain way, but also being able to hide in areas maybe in, camouflaging themselves or making themselves similar, mimicry, enough to make them think there's something, or maybe being in a space that they can't even perceive.
Right. Yeah, I think that my understanding of the whole thing with the host birds is that it seems to be they see like the triangular red shape of the mouth of the chick looking up, and they just feed the mouths, right? They just feed the mouths, so they don't distinguish about what the mouth belongs to, right?
Yeah. Yeah.
So anyways, so this is the beginnings of an outline of a case that really, if you're talking about environment, if you're distinguishing environment from the material objective world, not saying obviously the material objective world exists, but environment is certain elements taken from that by a set of genes which is composing out of the material world an environment that is relevant to its own fitness. And from making that kind of distinction, then I think the gene environment argument, we have to say that it really is all genetic.
Yeah, I mean, I would agree in the sense that the environment, like the inputs, is defined by the genes. Right?
That's pretty good. Yeah.
Like the inputs, like I to me, it's more clear when I say inputs, right? Like to me, because the inputs are defined by the genes, like in a sense, it's a function of the genetics. So it's genetics in that sense.
Patricia?
So I guess like just as a question to ask if this would be an appropriate analogy is, let's take humans in, I don't know, the year 1500. Radio waves would not be part of our environment. I mean, they're obviously there, but they wouldn't be part of the human environment until we figured out how to make a transistor or whatever. And then now they're a part of our environment.
Right.
Would that be like correct, or in terms of how we're defining these?
Probably not exactly. I mean,
no.
Still, our inputs are limited by like the visual spectrum, like what we can tactile, feel, what we can smell, what we can taste. All we did is build a device that allows us to detect it within the inputs we already have, right? So that the transistor turns, or that and some other stuff, turns it into audio, right? So a certain frequency of audio are within our environment. This is the inputs that we're able to perceive. And we changed radio into that, right?
Okay.
Actually, I guess we turned it into more than that because we use it for data now, and we put it on screens and other things. So, but we're still limited to like the inputs we had.
Okay. So yeah, okay. I gotcha.
Cool. So I'm glad I convinced you. See that, folks? I convinced them. Okay, there was a little bit of a word trick there, but I mean, but I mean, my point was to try and shift the way in which we view these things. And I think we have to maybe be more sophisticated about the way we talk about environment when we're talking about the gene environment relationship. And that's one of the ways in which you have to be more sophisticated, right? It really is the genes. There is no environment in the absence of the genes, and every cluster of genes / species or individual organism is evolved to create a particular environment for itself. All right. So, great. Folks. All right. Well, I enjoyed that. All right. So anything else before we go?
I don't think so.
Okay. All right. Well, that was fun. So, so you're still going to be with us, Patricia, for a couple more episodes before you go, right?
I think so. Hopefully, yeah. I'm going to be sort of gallivanting around, and I'm going to try and be on Reaction Norm as much as I can. But if not, Michael and Charles are going to hold down the fort.
Hold down the fort. All right, Ken. So until next time. Bye.
All right. Talk to you guys later. Bye.
Bye. Bye.